Hello everyone, welcome back to Geeks for Geeks Practice again. My name is Dhananjay Mishra, and today is in this session, it is a sort of editorial in which we will be discussing about the two problem statements. Hello everyone, that we solved. Welcome back. Yeah, we'll be solving those and coming back further. First of all, can you please acknowledge whether my voice is perfectly audible and everything is perfectly visible or not, so that we can start further. Once you acknowledge, yeah, everything is fine, so that we can move further and just discuss the question that we just about are about to solve here. Okay, thanks Karthik, thanks for this acknowledgement. So let us now, I hope that before moving further, I hope that all of you have enjoyed and just solved both the problems, and in case if you are not able, so that's why we are here, we'll be solving those problems. Okay, so moving back further. Okay, so let us now discuss those problems one by one. Okay, so the first problem was that like we were given a string. Okay, so in the first problem we were given actually a string, and the string consisted of the characters or the digits, I can say, of 0, 1 and 2. Fine. So now we have to determine that the smallest substring or the smallest window that we can have, such that the window contains 0, 1 and 2, and we need the smallest size of that substring or window, I can say. That means having a 0, 1 and 2 in them. So if you haven't seen this question, so this is the question, that we are given a string s consisting of the characters 0, 1 and 2, and your task is to find the length of the smallest substring of string s that contains all the three characters 0, 1 and 2, and if no such substrings exist, then we have to return -1. Okay, so if I take this sample test case, that is 0, 1, 2, 1, 2, then you can see that the string, that the size of the window or the substring, I can say, is this 3, that is 0, 1 and 2. Okay, so if I take this example over here, that is 0, 1, 2, 1 and 2, and if I do the indexing here, right, so this is the substring here, right? Why this one, why not this one or this one? Because as it said that if we consider a substring, and if we are assuming that it is our answer, then it should contain all the digits, it is 0, 1 and 2, else we are not considering that substring into our final answer. So if you have, okay, so the idea is pretty much simple, because if you have earlier solved the questions or another topic of the concept of sliding window approach, then you can solve this problem pretty much easier. Okay, so the basic idea is that you first of all create a window, right? You start from this pointer, this one, right? And you just maintain a window. So how do you maintain a window? You have a start pointer and an end pointer. Okay, so this one, so initially your window will be of size 1, that means your start will be here as well as your end will be pointing here, right? Your start and end would be at same positions. Now you will start sliding the window, that means the size, you will start increasing the size of the window, if you are able to get, or if you are valid, or if you are satisfying the conditions. That means the, what I can say, that the next character, or like one thing is that in the sliding window is that there are two things, right? In the sliding window, first point is that you need to find a way to increase the size of the window, right? First of all, to increase the size of window, and secondly, if if your current window is there and it is not satisfying any condition, like suppose in this case your current window size was reaching out to be this. Okay, because it was satisfying all the conditions, that means it was having 0, 1 and 2 as well, right? But now the question said that you have to find the minimum size of the window, right? You have to find the minimum size of the window. So because you don't know that whether it is the final answer or not, so you have to cross verify it, that whether, yeah, it is a perfect answer or not. So how will you do that? You will start decreasing the size of the window, and you will decrease the size of the window till the point your condition is not satisfied. That means, for instance, suppose, uh, if I consider this string again, that is 0, 1, 2, 1 and 2. Now considering that, suppose you considered this window, and now you wanted to fulfill or to check whether a window or smaller size exists. Con- you know a window or smaller size still exists, such that it consists all 0, 1 and 2. So how do you do that? You will just decrease the size of the window one by one. So this is the one way, right? And I have told you that how to increase the size of the window, but we will use this concept but in a different manner. Fine. So what I will try to do here is that maintain the, since we have only 0, 1 and 2, so I will just have 3 pointers. First one will be used to point the latest index of this 0 occurring. Second pointer will be the latest occurrence of this one, and my third pointer will be denoting the latest occurrence of this 2. So latest occurrence will be denoted by the indexes till at which these 0, 1 and 2 are occurring. Fine. So how will I do that? Suppose if I take this one, that is 0, 1, 2, 1 and 2, and if I do the indexing here. Fine. So how will I do that? I will first of all start iterating my this string. I will start iterating my this string, and as soon and at each pointer or at each iteration point, if I occur, suppose if I occur 0, then I will update my pointer value of 0 as the index 0, because 0 was occurring at this index. So initially all of them were pointing to -1. Fine. Initially all of the three were initialized as -1. Now since I am occurring here, I am at 0, then I will update, because 0 is the latest one, right? There is nothing before 0. This is the latest and the last, I can say. So my 0 will be, index of 0 will be updated to 0. Fine. Now I will shift again to 1. So my 1 will be, what will be at this point? What will be my latest index of 1 or latest occurrence of 1? That is 1, right? Because 1 is occurring only at this point, till this point. So index will be 1. Now if I move on to 2, right? Now at the next iteration I will be at second index, and I am facing a 2 here. So I will update my latest index of 2 here also, right? So it will be a 2. Now again I will move on to this, right? So now one more thing is that at each point, what I will do, at each index when I'm pointing to, I will check whether it is a possible answer or not. So how will I do that? Because I know that I have the latest occurrence of 0, 1 and 2 as well. That means I will check if any of the pointers pointing to 0, 1 and 2 latest occurrence is not equal to -1. That means we are having a valid indexes values of these 0, 1 and 2. As you can see here, the occurrence of 0, 1 and 2 are 0, 1 and 2. So what I will do, I will check my answer. What will be my answer at each index? My answer will be equal to minimum of, because I have to find the minimum size of the substring, right? Minimum of I current index I am pointing to minus I will take the minimum of all those occurrences, right? I will tell you why I am taking the minimum of all those occurrences, and plus 1. So I will, at each index when I am pointing to, I will get my answer by this formula. How? Why I am doing that? Suppose, okay, for instance, if I am here again, right? So if I am at this point currently, then what is the minimum of 0, 1 and 2? That is 0, right? And what is my current index I am pointing to? At this one. So you can see that my window is this one, that is 0, 1 and 2. That's why I'm taking the minimum of both of all of these three. Again, you will understand it more better. Okay, now yeah, Manik, I will explain it again. First of all, just have a summary of this approach, what I'm trying to do. So again, at the last point I was here, right? Now I will again move to this one. So you can see that my index of this one, is will be updated to what? Updated to 3, right? So it will be updated to 3 here. But since now, how I'm checking my window size? I'm checking my window size by subtracting the minimum of 0, 1 and 2 with the current index I'm standing at. So if I'm standing at this index, then what is the minimum of 0, 1 and 2? That is this 0th index, right? So my window size would be this one. Now, okay, so I will explain you again that what is the idea. The idea is that I will maintain the latest occurrence. I will repeat again. I will maintain the latest occurrence of 0, 1 and 2. Right? Because I want to have a window in which all 0, 1 and 2 are there. So that means I will have the latest occurrence of 0, 1 and 2. right? And once I have all the occurrences of this one, so how will I find that my window, that, or I can say that how will I determine a window? So I will determine a window by subtracting the current index I am pointing at minus the minimum of 0, 1 and 2. Why I'm taking the minimum of 0, 1 and 2? Because I have to consider a window in which all of them should be there, right? And since I want to find the minimum of the window, that's why I'm taking the minimum of 0, 1 and 2. If I consider another example, okay, if I consider another example for you, that is 0, 2, 1, 0, 1, 2, and let us say 1 here. So what should be the answer? The answer should be again this 0, 2, 1, and right now. But what can happen? The latest, so if I for this string, if I maintain my 0, 1 and 2 pointers, it is 0, 1 and 2 pointers. So initially my latest occurrence, if I'm at this index, right, if I'm start iterating my string, and if I'm at this 0 index, right, so my latest occurrence of 0 at this point, up till this point, was 0. Similarly at this index, at this point of iteration, I am having a 2. So what will be my latest occurrence of 2 here? That is first index, right? That is, it is occurring at the first index. Fine. Then I'm coming back to 1 here. So the latest occurrence of 1 I have currently is what? 2, right? Now I have to, at each index I'm trying to find out, because I don't know at which index I'll be getting my maximum answer, or my optimal answer, right? That is the minimum size of the substring. So that's why I'm checking at each index the current window that I can form, having the final answer. So if I'm at this index, then I will check whether my 0, 2 and 1 are having a valid index values. That is, yeah, 0, 1 and 2 are having a valid index values, because initially they were initialized to -1. So yeah, I can form a window, right? But I have to check whether it will be the minimum one or not. So I am pointing at this index currently. So what will be my window formed? My window formed will be this one. Fine. So how do I check this window? I am currently standing at this index, that is at I. And I will take the minimum of 0, 1 and 2, because I have to find the minimum size window, right? That's why I'm doing minimum of it. You will understand this formula, why I'm taking minimum, again when I will do the remaining iterations. Okay. So that is 0, 2, 1. So you can see that the minimum occurrence of all of them 0, 1, 2 are this 0. The 0th index, right? So I will take 0. So you can see the answer should be equal to, this is the second index, right? This is a second index. So if this is second index, then here the formula will become out 2 minus minimum of 0, 1 and 2 is currently for this window. For this window, the minimum of 0, 2 and 1 is what? 0, right? So I will have 0 plus 1. So you can see the size of the window is coming out to be 3, and it is, you can see here, at 3. Now I don't know whether it is a final answer or not. So I will again try to move and do the all the iterations till my strings get exhausted. So again, at next iteration I will be at this one, at this 0, right? So my latest, as I said, that these are my latest occurrences of 0, right? So if I'm at here, my latest occurrence of 0 would be updated. So it will be updated to what? 3, because it is at third index, right? It is at third index. I will do the indexing for you. 0, 1, 2, 3, 4, 5 and 6. Now you can understand it better. Now again I'm here, right? Now again I will try to check whether I'm getting my final answer or not, right? So now these are my latest occurrences. Again I'm at this index, right? I'm at this index. So what will be my answer? I minus, that is 3 minus minimum of 0, 1 and 2. So what is the minimum of 0, 1 and 2? That is at 1 index, right? This one. So that's why I'm getting again a 3. Now again, if I move on to this index, so my latest occurrence of 1 would be changed to what? 4. It would be changed to 4 here. Now again, if I'm at this index, I will try to find out my window. My window which is having all 0, 1 and 2. So you can see that what will be my window? The minimum of these one, right? Because as you can see, why I'm taking the minimum, because if I take the minimum of all of them, and I know that I have to consider a window such that having all 0, 1 and 2. So here the index of latest index of 3, or if 0 is 3, 1 is 4 and 2 is 1. So what will be my window? My window will be this one. Why? Because the minimum of all of these occurrences is 1. So this will be my window. This will be my new window, right? But my current answer is 3 and its window size is 4, so it will not be updated answer. Okay, I hope that you got the approach of it. So if I move to the code, so it is the code right here, right? So what I have taken here, I this is my function that I have to complete. It is having a string s parameter and the return type is integer because I have to return the size of the window or the substring, right? If I repeat that, or I can say the minimum substring, right? So I have first of all took the boolean variable, that is answer exists. Why? Because that might also happen that there are the string contains all the digits only 2 and 1, there is no 0. Then in that case our answer will be failed, right? Because if I take this window, that is 1, if I take this string 1 2 2 1 2, so you can see that there is no 0. And what was the condition for forming a window? The condition was that we should have a 0 as well. That means all of them should be there, that is 0 1 and 2. Okay, first of all, we will take a look at the code and then I will tell you Sri Atitya Krut that how I came up to this approach. Okay, so yeah, so we have, that's why we had this bool answer exists equal to, first of all, initialize to false. Then as I said that I will have 3 pointer pointing to the latest occurrence of 0 1 and 2, that is the last 0. I can say last or the latest one, right? Both are interchangeable. That is int last 0 minus 1 initialize minus 1, last one initialize minus 1, the occurrence of 2 is initialized to minus 1, right? And this was for the size of the string. Now as I said that if I encounter a 0 character, then I will update is, update its latest index as like when I'll be just iterating my entire string, right? So at the end, like now, this is the logic where I'm checking my window size. As I said that if I am having all the valid indexes or occurrence of 0 1 and 2, that means if none of them is equal to minus 1, that means our answer exists, right? And what will be my answer? Answer equal to minimum of answer comma I minus, this is how I check my window, right? This is the line of code for checking my window. I minus minimum of all the occurrences and adding a 1 to it. Why I'm adding a 1 to it? Because you can see that if this was my window, that is 0 1 and 2, so if I subtract 2 from 0 I will get a 2, but the answer is 3. That's why I add a 1 over here. That is 2 minus 0 plus 1. Fine. So and yeah, and when the loop gets over, all the iteration of the over the strings gets over, I will get my final answer. And if not, then I have to check whether my answer exists, a boolean variable is set to true or not. If it is set to true, then I will return my final answer, else I will return a false denoting minus 1, that is there is no window or substring having all the 0 1 and 2 together, right? So yeah, now as Aditya asked that how did I got to this normal, like this approach from normal sliding window. Now Aditya, as you can see that as I explained earlier from the sliding window, that when you decrease the size of the when you start decreasing the size of the window, right? What do? You start decreasing one step one by one, right? So if suppose if this was your window, right, and you want to find the minimum answer, what did you do? You do in the normal sliding window, you just decreasing the size of the window from the left part one by one. But why do we do that? There's no need, right? Because if I have the latest occurrence, of any of all of them 0 1 and 2, then there is no need to delete one by one. I can directly reach to the point or that character. If I remove that character, then also I will have 0 1 and 2. So that's why I have that 3 4 and 1, right? For instance, uh, if I take this one, that is 1, okay, again 1, again a 1, and 2 0 1, and let us take a 2 another, right? So what did you do? In the normal sliding window, you will have your answer at this point, right? And then to find the minimum of the window, what you will do, you will one by one decrement the size of the window by removing this. First of all, you will remove this one, and then again the next step you will start removing this one, right? But I just wanted to optimize this thing. I don't want to have overheads, that why do I need to traverse them again and again to decrease my size of the window? if I can have the latest counter or the latest occurrence of the 1. What? Because as you can see that here, because of this one, of this repetitive one, I have to decrease my size of the window. But what do I say? What if I just have the latest occurrence of this one? So if the latest occurrence of this one is this one, so I will directly fetch my answer from this window. From this window only, right? There is no need to decrease the size of the window by by deleting this one first and this one first, right? I hope the idea is clear to Aditya, how I just got to this optimized approach of the sliding window, right? Because there is the idea was that if I know that because or if I know that uh, if this one is the character due to which I have to decrease my size, then what if I just have the latest occurrence of it, right? Because if I have the latest occurrence of it, then there is no need to one by one shifting or decreasing the size of my window. I can just directly come out to this point by having my latest occurrence of this 0, 1 and 2, right? Whatever the character is repeating. I hope that the idea is now clear to you, Aditya, right? And still, if anyone has any doubt in this approach, you can just ask me. Then we can quickly move further to the next question. And one more thing that I just forgot about time complexity, right? If you just, Aditya, you can just understand the difference between these two approaches. Okay, so in case of normal sliding window, in case of normal sliding window, the time complexity would be near about O of n, right? But you go in depth, it is O of 2 into n. Why? Because in the worst case, what you can do, you can when the first time you will iterate any character would be when you increasing the size of the window, but the second time you will be accessing or facing that character again would be when you will be decreasing the size of your window. So that means overall you will be fetching each character twice at max. So the time complexity will become O of 2 into n, right? But when I apply my optimized approach, I will only fetch each character only once, right? So that's why the time complexity will remain, all about equal to O of n, but it is a more optimized one. It would be O of n, right? So this was the approach, and the time complexity, the space complexity would be remaining O of 1 in both the cases. Now moving on to the next problem. So it is a very interesting problem, right? Because the first problem was very easy if you know the concept of sliding window, right? This is a very interesting problem. So what does this problem have for us is that, okay, this problem says that we are what we are having we are given a binary search tree. Okay, the problem says that we are given a binary search tree, and we are having two nodes in that BST which are swapped with each other, right? So in the binary search tree, if I swap two nodes, that means it won't be remaining a binary search tree as it is, right? For instance if I consider an example, right? First of all, you just need to understand the problem well, then can only you can solve to or get a solution to it. So if I consider a BST, right, that is, if I consider a BST having the value, suppose 10, we have a 10 here. Okay, we have 5 over here, we have 15 over here, and let us take a 4, a 7. What else can I have a 14 over here, and I can have a 20 over here, right? So consider this BST. Now, as you can, if you know that the property of BST is that the left child of a node is lesser than its parent node, fine, and the right child of that node in a BST is greater than its parent node, and this property is followed by each and every node in the right subtree. As you can see that this 14 is although being a left child of this 15, but it is, first of all, it is the right child, it is in the right subtree of this 10. So that's why its value, you can see, is 14, it is greater than 10. So that's why it is a valid BST, right? It is a valid BST. So this is the property of BST. Now what I do, I just swap both of these values. I swap this value and this value. Now what will my BST look like? My BST will look like something this, right? If I swap these value, 15, I have a 5 over here, consider a 4 over here. Okay. So now do you think that it is a valid BST? No, definitely not, because the property of BST says that in the left child of a parent node you have a value which is lesser than the its parent, right? So as you can see that 15 is greater than 10 in its, and it is in left child. So it is not a valid BST. Why? Because we swapped both of these values, right? Now what the question says, we are given this distorted BST, or I can say a disturbed BST from a valid one, right? So I have to find out, or no, or what I can say, I have to, what I can say, I have to just convert this BST into a valid one and return the node of that valid BST, right? I have to return the root. So one more thing that you have to first of all analyze here is that only two nodes of that BST is swapped. Only two nodes are swapped. The remaining nodes are perfect at their places. That means the remaining nodes are not disturbing the property of BST. Only those two nodes which are swapped with each other are disturbing the property of BST, and that's why you have to again reorder them or replace them at their perfect positions to form a valid BST like this one. So this was the question, right? Now how can you solve it, right? So this was the question you can see here. Okay. Now how can you solve it? So the basic idea that is coming to, like, what we can do here is that first of all I just do a normal traversal of this entire tree, right? Or before moving to this approach, right, the naive approach that comes into everyone's mind is that, as I know that apart from these two nodes that are swapped, all the other nodes are correct one, right? So if somehow I apply any approach and I get to the two nodes which are not allowing my this BSC to be a valid one, right? Then, and if I find these two nodes and then I swap them at their perfect, because, and I swap them with each other. Why we are swapping them with each other? Because initially if this was my given PST, then I swapped these two nodes with them, right? I swapped these two nodes amongst them. So if I find the two nodes which are swapped and I then again replace them, then it will be again at their same positions, right? Because I have not touched any other node. I just swapped these two nodes, and if I again swap them with each other, then I will get this answer again. You can see that, right? If I swap them again, I will get this answer again. So the idea is that first of all we have to find those two nodes which are swapped, and once I find them I will swap their values, I will get my final answer. How can I solve them? So the basic idea is that if somehow I just have all these values and find out the nodes which are swapped, so the basic idea coming into my mind is that I just do, since it is a tree, right, I just do a normal traversal of it and store it into an array, right? Because how do, if I give you an array, if I give you an array, then how do you convert it into a tree? You can convert that array into a tree, right? Because if you use the formula of 2 into I plus 0 and 2 into I plus 1, right, where I is the parent node, then you can convert that array into a tree, right? You can do this in this manner. This is a different topic, right? But now the idea was that find the two nodes which are distorting this our original BST. So if I somehow iterate my this traverse my this entire BST and store them into an array, and then sort my BST, sort this traversal entire, because if I sort them, if I sort them, then I'll be using the then I can use the property, right? Because if I sort them, then I can use the property that in a sorted array, what happens, that the previous value is always lesser than the next value, right? So one thing is that now we can utilize the property or fact of that, the fact that it is a BST, right? So if I somehow store all the nodes into this array, then do you think that there is really a need to sort this entire array? No, right? Why do you need to sort? Because if it is a BST, then all the nodes in the left hand side, in the left subtree of this node is lesser and the right is greater, right? So if I do the in-order traversal of this BST, as you can see, if I do the in-order traversal, so what is the in-order traversal? Left node, middle node, and this right node. So if I do the in-order traversal of this tree, so what will I get? I will get, if I do the in-order traversal of this one, so what will I get? I will get a sorted array by default. right? So that is I will get 4, 5, 7, 10, 14, 15 and 20. This is the in order traversal of this above tree. Why? If you don't know about in order traversal, I will make you just analyze it. So as I said that first of all we reach to the leaf node, and then from there I go to left, root and right. So as you can see left 4, root 5 and then 7. Then again I go to this parent. It is already visited, right? So I will go to this one, and again I will go to depth, right? Because it is a DFS kind of approach, right? So you go in depth, then you will come to here 14, then 15, then 20. So it is the in order traversal here, right? And you can see that since it is a BST, and this is the property of BST, that if you apply an in order traversal on a BST, you get a sorted array. Since I get this sorted array, right? And you can see that since it is sorted array, you can see that if you take any pair, then the previous value, if I consider this pair, if I take this pair, if I take this pair, then the previous value of this pair will be lesser than this value. You can take any pair, you can take this one also, you can check for this one also, right? But if my BST is distorted, is is touched, or is shifted a bit, like in this case, so what will be my traversal? What traversal of this distorted BST will give? Let us see. So I will get the traversal as 4, 15, 7, then I will go to 10, then I can again go to 14, then 5 and 20. Now you can see here that here, if you take this pair, you can see that the properties of a sorted array is disturbed here. That is, this first element of this pair is greater than this one. That means there is something messy in this pair, right? And again, you can take this pair. You can again see that, yeah, in this pair also, the previous value is greater than the next value, right? So that means you in this way you identified that these two pairs are are somewhat a fishy pair. That means these two pairs will be having my element or the nodes which are swapped with each other, right? And how do I find it? Okay, so as you observe from here, from this one, that if you have found this pair, right, and this pair also, so what you will do, if you do just a bit of observation, because if you take the first pair's first value and the second pair's second value, right, and if you swap both of them, then you will get your final accurate BST, right? So this is the approach. Right? You will first of all get a first you will first of all what you do, you will first of all do the in order traversal, right? You get the in order traversal of this entire BST, and after that you will be finding those two pairs which are which are not following this property of a sorted array. And how do you find that approach? You will traverse this one, right? You will traverse the in order traversal and check whether the previous one is greater than the next one, or the next one or not, right? If it is, then you will maintain the previous counter here, right? And here again you will see that if again you are finding that, that means then in that case you will be storing the last pointer here, right? And then since you have the information of both the nodes that are swapped from the original BST, you can again swap them and have the final answer. Now this was the case if you solve them and store them into an array, right? So the time complexity would be O of n if there are n nodes, and the space would be also O of n because you're storing them into an array. But now I said that I don't want to use an array. Then how do I do that? That means I don't want to store them externally then, right? So I will move on to that approach also. But first of all, there are two cases in this approach also, right? The first case is that the two nodes that are swapped with each other, are adjacent, and the another case is that when they are not adjacent. So this is the case in which you can see 15 and 5 are not adjacent to each other, right? What do I mean by adjacent? That means 14 and 5 are adjacent, 5 and 20 are adjacent, 10 and 5 are adjacent, right? That's what I mean when I say the word adjacent, right? And the other case might happen The other case might also occur that if this was 5 kept as it is, right, and the case was that I just swapped the 14 and 15 over here, right? If I swap them, so here you can see the sorted array. This in order traversal would become 15. 15 would come first. 15 would come first, and 14 would be coming out here, right? Now you can see that there will be only one pair, right? This pair would be deleted, right? Because this is the sorted one, right? There is only now one pair. Now how do you will if you follow the previous approach, if you follow the previous approach of finding two pairs, then it will not satisfy this condition, right? So that's why in this case that might also happen, that if the adjacent nodes are swapped, then you will find that pair, right, and just swap the both of these values, right? So now I will tell you, this was the case when you store them into an array, right? So before moving to the best or the optimal approach, I will just like to have the doubts, like, because whether the approach is clear to you or not. Yeah, yeah, Aditya, when I said that I want to swap, I will swap the nodes value, the value of the nodes, right? Okay, Vedant is asking how to do in O of one space. Yeah, so I will now discuss the O of one space solution. But before that, I hope that all of you have understood this approach, right? What is the basic idea behind it? Okay, I hope that everyone have understood this idea and approach. Now, how will I solve it in O of one space, right? If I don't store the values in the array. Okay, so what will I do? I will start traversing my this BST. Okay, so if I consider, uh, if I just have the previous values here over here, right? Okay, now what will I do? If I, if you do that in our traversal, right? So, uh, okay, let's start traversal over here, right? Considering that it was a given BST or the swapped BST. So the swapped values were over here. It was a 14 over here, and this was a 15, and it was a 5, right? Yeah. So now if I start from, because this was my leaf, right, in our traversal I start from this 4. So if I'm standing at this 4, right, so I will maintain first of all 3 pointers. The 3 pointers would be the first, 3 pointers would be the first, the previous, and the last, and all of them will be initialized to null. Okay, all of them will be initialized to null. So what I will do, if I'm currently standing at a node, right, then I will be storing or updating its previous node, because you can see that what I was trying to do, I was trying to find a pair, and if I'm at the first pair, or it was the first time when I encountered such a pair that the previous value was less than the next one, then I will have the previous value over here, right? And the second case, and the second time when I found the same pair such that the previous value is greater than the next pair, then I will have the last value over here, right? That's why I have these 3 pointers, first, previous, and last. You will get to know the use of them when I will do the dry run of that code, right, with you here only. So suppose if I am at 4 over here, right, so there is no previous value for it, so I will jump to this next node, 15. If I am at 15, I will check whether, so if I'm at 15, I will update my previous one. So my previous one will be this 4 node with value 4. Now I will check whether my previous one is greater than 15 or not. Because if I'm currently standing at this one, so my this 4 would become previous, and this one will be my current node. So this would be my equal to root, right? This will be, current will be equal to my root, because if I'm currently standing at this one, this would be my root, and this will be roots left, this will be roots right, right? So if I'm at this one node, so this is my current node and this will be my previous node, then I will check whether 4 is greater than, or the previous node's value is greater than this one or not. Why? Because I want to find a pair such that the condition, this, that is the first one, previous node is greater than the next one, is satisfied. So now I will not say greater one, the next one, I will say the current node, right? So if I'm at 15, the condition is not met. Now again, if I jump to 7 over here, if I jump to 7 over here, you can see that its previous value will become equal to 15 and the current will be at this 7. So I have found the pair where the previous value is greater than 7. So this was my first pair, right? This was my first pair. So if this was my first pair, that means that my first node's value or the address at this is actually a pointer, right? So the node at which this first is pointing is initially equal to node is equal to null. So if it is first pair, then initially it will be equal to null, and hence if it is null, then it denotes that yeah, it is my first pair, right? You will get to know why I'm saying that, right, when I get to the second pair. So initially, if it was my first pair, it is the first time that I'm encountering such a pair that the previous value data is greater than the current one, that is 7 1. That means, and because if it is the first time I'm getting a pair, that the value of first will be equal to null. So that's why I will update, I will what I will do, I will store my first value as previous data, right? I will have first as equal to previous, right? Now again I will update my, because this is my second value of this pair, right? So I will have my last pointing to this one, so it will be my last. Fine. Okay, now again I will, so my first is initialized to, I will write here, right? I will write here. So my first is, or one more thing I can do here is that I can just update over here itself, right? So if I am at current, my first previous was equal to 4, right? And then my next previous become 15. So for 15, there was nothing find. Then my next previous, so yeah, so when my next previous became equal to 15 and my current was 7, right? Then I got the answer, that is first. So my first value became equal to 15 and last became equal to 7. Fine. Now again I move to 10. So if I move to currently 10, then my previous will be become equal to 7, right? My previous will point to this 7. So again I will check whether 7 is greater than 10. No. Then again I will shift my next to this 14. So if I move my next to this 14 or my current, then currently I am standing at this 14, right? So my previous will become equal to 10. Then again I will check whether my previous is greater than this 14 or not. No, it is not. Then again I will move to this 5. If I again move to this 5, what I will see? I will see that yeah, my previous will become 14. I will see now at this again point that my 14 is again greater than 5. But now how will I consider? Because what I said, for the second pair that I find, I have to store the second value of that pair. Now the point that I said, that if my at the first pair which I have found here, my first was set to null. But now since I have encountered this first pair earlier, my first is now not set to null. It is set to this 15, or it is pointing to this node with value 15. So here I can easily point out that yeah, it is my second pair. Why? Because my first is not pointing to null. That's why I will now store, because I am confirmed that yeah, it is my second pair. That's why I will store the last and update the last as here equal to 5. And now when this all the iteration is over, all the in order traversal is over, I will get this updated value of first and last, right, denoting that these two nodes were the disturbed node. Then after this traversal is over, I will have this updated first and last node. Then I will update, then I will swap their value and return the root of that BST. Now one more thing, you can sense here that at each pair I am updating my last again and again. I have not written over here, but actually what will, if I consider this pair, if I consider this pair, that is 4 and 15, so my last would be set to 15 first. My last would be set to 15 first at this 4 15 pair. Then again it will be shifted to 7. Fine. Then again it will be shifted to 10, 14, and at the end it would be shifted to 5. Okay. And when it will be done, so it will be done, okay, wait a second. And it's okay, so what actually happens is that whenever you find a pair, whenever you find a pair, I just said this wrongly here, okay, right? Whenever you find a pair such that the previous is greater than the current node, then you will update the last one. So here the last one will become equal to 7. Again here you find the another thing, another pair, you will update the last over here as 5. Right, now you will be, having a doubt then how this approach will work when there will be only one pair, right? That means that the adjacent nodes will be swapped. So in the case of adjacent node, what was our in order traversal? That is 4, 5 was here, 7, 10 and 15, 14 and 20, right? This was the in order traversal when 15 and 14 node values are swapped. So you can see that there is only one pair over here, right? There is only one pair over here. So I am finding this, so I will update my first and last also here. So my first will become equal to 15 and my last will become equal to 14. And since I am not finding any another pair, my first will be remaining as it is and my last will be remaining the updated value is 14. So once my this another traversal is over, I will swap these values and I will get my answer. Okay, so now I will move to the coding part, but before moving to the coding part, just to know that why Satyam is asking, he is getting difficulty in getting the approach. Satyam, I hope that now I have explained it clear. I hope that the approach is now clear to you, right? Because the idea is that the basic idea is that in order traversal, because if I do the in order traversal of a BST, I get a sorted array, and from that sorted array, if the BST is fine, that means all the pairs will satisfy the property that the previous value of that pair will be smaller than the next value of that pair, right? As I explained it here, you can see that if the BST is perfectly fine, then if I consider each pair, then you can see that in each pair the previous value will be always smaller than the next value. But if the BST is distorted, the values are swapped, the two values are swapped in that BST, that means this property will not be satisfied, because you can see that in this pair 15 and 7, the previous value is greater than the 7. That means there is something wrong with this pair and this pair also, right? So that's why with the help of these two pairs I am finding out further that what are the nodes that are swapped. Fine. So how did I find out that if I get these two pairs in the first pair, I will store the first in the first pair I will store the first the element of that first pair, and the second pair I will store the second element of that pair, and then I will swap them, right? But this was the case if the nodes swapped are not adjacent, this one. But what happen if these adjacent nodes are swapped? So this was the case when the nodes are adjacent, right? In this case you won't be finding two pairs, in this case you will only find the one pair, and in that case you will have only these two values. That means you will swap the first and the last value, the first and the second value of this only single pair. Okay, so this was the approach. Now I will move to the coding part to show you how it is done. Okay, how to implement this approach. So this is the approach, guys. Okay, so as I said that I have globally declared this pointer, that is first pointer, pointing to the first value, right? The first node, the last denoting the second node, right? And the previous node denote, because I have to store the previous value for this iteration, right? I have to store the previous value at each for each and every pair. So yeah, so now this was our main function. So I called this solve function root, which is basically the in order traversal over here. So how do I do in order traversal? First of all, I will check if I am currently pointing a root or a node which is not equal to null. If it is null, then I will return from that point. So to understand this approach perfectly, you should first of all know how does in order traversal work. And if you have not solved that, then you can then you can go to practice channel. We have a video uploaded over there for the in order traversal of a binary tree, right? So in case of BST, if you do the in order traversal, you will get a sorted array, right? So first of all, in our traversal, we go on calling the left child again and again, and then in the middle we perform some computations, and then we again call the right child. Okay. So as I said that first of all, we after doing this we will go to the leaf node, and then I will check whether my previous is not equal to null, because if I'm currently standing at the leaf node, at this leaf node, then its previous here is null. Fine, so I cannot check that. And if my previous is not equal to null, suppose if I'm standing at 15 over here, so its previous is 4 over here, right? Its previous is 4 over here, you can see that. So now it is a valid previous value. So I will check if my previous data is greater than the root data, because currently I'm standing at this node and it is my root, right? Or I can say the current node. So I will check if it is valid, then I will update my and now here I say here by this first equal to null condition, I check whether it is my first pair or not, right? So if it is my first pair, that means the first value will be always be equal to null, and it will not be modified because it is the first time I'm encountering such a pair, right? So if it is that, so as I said that if it is the first time you're encountering a pair, and or I can say if it is the first pair, then you will store the previous value over here in the first one. So I have stored the previous value in the first one over here, right? And simultaneously, if this condition, as I said, that you will be simultaneously storing the last value. So the last value will be the current. If you're currently standing at this one, right, then it is the root. So your last will be for this pair, your first will be this one, and last will be this one, right? Right. So now, as I said, that you have to, if you move again further, you have to update your previous, because if for this node, your previous will be updated from this 15 to this 7. So you do this here, and then you again call the right. Right. Now, at the end, when this in our traversal will be over, as these were all the pointers were the global pointers, right? So their value will be updated and they will remain as it is in your entire code. So that's why I have taken them global, right? So since they are global once, and therefore once the traversal is over of this solve function is over, then you will have your updated first and last, and then you will swap these value, you will get your final answer accepted, right? And then you will return the root node. So if I try to submit it over here, it will get accepted. Okay. Yeah. So this was the guy's entire approach, and the time complexity is O of n, that and n is the number of nodes over here, and the space complexity is O of 1. Right. So yeah, guys, this was all about these two questions, right? And these questions, trust me, were very interesting question. The first one was on the based on the concept of sliding window, and we saw how can we optimize the sliding window concept, right? And the second problem was this BST or based on tree, right? It is a very interesting problem. So yeah, guys. So I hope that you enjoyed this contest entirely. And guys, stay tuned for more such contest of of this unboxing interview series of or such big tech giant companies. So guys, stay tuned. Yeah, I'm updating the okay, Satyam is Aditya is asking. I'm updating my previous pointer. So you can see that I'm updating my previous pointer over here. Previous equal to root. Right? Once I'm done with these updations, I'm updating my previous over here. Abhishek is asking, explain once more. Okay, Abhishek, I will just summarize the idea, right? The idea is that because it is a BST, right? Because it is a BST, and if you do the in our traversal of that BST, you will always get a sorted array. And the property of a sorted array is that if you pick out any of the pair, if this was my BST and this was the in our traversal, so if you pick out or choose any pair, any adjacent pair, you will see that the first value of that pair will always be lesser than the next value. But in case the BST is distorted or the values are swapped of any two nodes, so you can see that the inner traversal of this BST is this one. Fine. So you can see that if I pick these two pairs, the first value is not smaller than the next one. It is greater than the next one. Why? Because these two values are swapped. Now from these two pairs, I'm finding out what are the two nodes that are swapped, and once I get the information about those two nodes, right, I will swap these two nodes again and I will get my original BST. That was the idea. Yeah, Satyam. Yeah, the questions basically, if I, frankly speaking, the questions basically nowadays, are just based on competitive programming, right? They're in the format of a competitive programming, right? So don't worry. But basically, what you have to do, it varies on company to company, right? How do they design their questions? But basically, you have to just know all the concepts over here. And yeah, as you can see that we are having all the interview questions over here that are generally asked or that are previously asked in the coding round of that particular organization. Suppose for if I'm currently taking this session of Paytm, so these were the coding round questions of Paytm, right? So they are asking such type of questions in the coding round. Okay. So you have to solve. So you should be ready for any type of questions, right? Okay. So yeah, if anyone has any doubt, you can again ask, and then we can wind up this session. Okay. I hope that no one has any doubt. So yeah, we can wind up this session. So guys, stay tuned for GFG for because we are coming up every week with such interview series and unboxing of these series. I was not able to solve both the questions. So how do you suggest improving? Is there some course I can do or something like that? Yeah, Aditya. Okay, I have one thing to say to you, right? Because basically, when the people say or the students say that they are not able to solve the problem, the basic issue with them is that they are not aware of the concepts that are used in that particular problem. For instance, in the previous problem, that is this one, if they're not aware of the, or if they are not aware of the concept of sliding window, or they have not solved the accurate or the sufficient amount of problems on sliding window, they will not be able to fetch the current idea of that, right? And in the coding round, it's all about the speed at which you solve. Suppose this contest was of around 1 hour or 1 hour 30 minutes. And suppose you are able to solve this question, but at the end moment, because at the end moment you are able to understand that what the actual concept is. So there is no point because you have to solve the another question also, right? So the basic idea is that you should know each and every concept over here, right? And the second question, the concept was BST and the inward traversal. So because if you don't know, if you previously didn't knew about this concept of that if you do the inward traversal of BST, you get a sorted array, because the basic idea lies behind for this question lies behind this concept that if you do the inward traversal of this BST, you get a sorted array. So you have to first of all know the all the concepts, right? First of all, get to get your hands dirty with all the concepts like arrays, all the concepts involved in arrays, strings, sliding window concept. That is a basic, most basic concept involved in question of strings and arrays. Fine, hashing, right? Some bitwise operations, the questions on trees, dynamic programming, recursions, right? Graphs. So you have to first of all get comfortable with all these concepts, because that should not happen, because it is a contest based on time. It is not some sort of code chef long challenge because in which you have a 1 week challenge in which you can learn the concepts and all solve. No, it is the concept. It is a contest in which you get maximum of 2 hours only, right? You have to understand the problem statement and solve them, and you can only do that once you have previously solved the problems, right? So you have to first of all, as you asked, like how do you can improve, you can improve by just knowing the concepts or the prerequisites earlier, right? So that's what you can do. And once you're done with that, just pick a topic, solve 10 to 15 questions on that. I will not say 10 to 15 questions for everyone, because every individual is different, right? They might require different types and different amount of questions to understand that concept particularly, right? So it depends on individual to individual, but on an average you should solve 15 to 20 questions, right, of each topic to get your hand set on them, right, and understand each topic in depth. One more thing, if you solve a question, don't mug up that question. Understand the logic behind that. Right? Don't mug up that question. So that's all I will suggest to Abhishek. Okay. I hope it will help you in near future. Okay. So yeah, I think that how was swap function implemented? Rough idea, please. Do I need to traverse the tree in order and swap? Basically, swap is a uh, this swap function if you're talking about. So basically, this swap function is an inbuilt function in C++. If you want to implement by yourself, you can just create your own swap function, pass the two parameters, their types, and just have some pointers and addresses, and then you can swap the addresses of that thing, and you can swap these values, right? So there is an article of GFG where you will find how to swap these things, right? Trust me, it is a very easy question, right? It is a very easy utility or utility function, swap function. Don't worry about it. You can directly use this swap function as it is. Okay. Thank you, Satyam. Thank you for this appreciation. Okay, Abhishek is asking that he's coding in Java. So I don't know about Java. If I think that there are a lot of inbuilt functions in Java, but if there is not swap function in Java, then what you can do is you can just I will just give you the prototype of that swap function, right? How you do it. Suppose in this case the values here were the integer type, right? So what you can do over here is that have this int st something kind of thing like data, and this x value, or if you pick up these values, right? Because basically you want to swap these values, right, and swap the data in them. So that's what you do, you just have to have the addresses of both of them. But in Java there is no concept of pointers and addresses and all, right? So I'm not confirm about Java, but you can google it out, or just you can find out the article that how to do the implement a swap function in this Java, right? Okay, thank you, that helps a lot, really appreciate it. Thank you, Aditya. Thank you guys for all your appreciation and your time. So guys, stay tuned for GFG more for more such videos. for more such informative videos, I will say, right? So yeah, guys, stay tuned to GFG practice. Stay happy, stay safe, happy coding. Bye bye, and all the best for your future endeavors. Because all the guys who are currently in the fourth year, they will be having their placement coming near about. Okay, so all the best for your future endeavors. Right? Don't worry. Just have faith in you and in your all the learnings. Right? Okay. So all the best. Good luck. Bye.